A methane graph rises above its usual baseline. Even though the rover is sitting in a place where nothing obvious appears to be changing, inside Gale Crater, Curiosity keeps taking measurements, and some of those readings show methane levels jumping by a few parts per billion. The surface looks the same, the numbers do not. Scientists pay attention almost immediately because methane is one of those gases that can become important very quickly. On Earth, a large share of it is connected to living things. That does not make the Mars signal proof of anything, but it changes the conversation. A measurement that once looked routine suddenly looks worth chasing. The evidence comes directly from Curiosity's instruments. The rover records the spikes. The graph climbs. Headlines follow. What had been a quiet search for environmental data starts attracting attention as a possible clue about something much larger. For the moment, the system appears to be working. Methane is being detected. The readings look significant, and the possibility of life becomes harder to ignore. One question stays unresolved and keeps pulling scientists back to the data. Why is methane there at all? A chart fills with new arrows and labels. One path points toward biology. Another begins deep underground, where water moves through rock and chemical reactions produce the same gas that caught everyone's attention in the first place. Researchers build models around a process called serpentinization. On Earth, similar rock-water reactions can generate methane without any involvement from living organisms. The result is uncomfortable in its simplicity. The methane molecule coming from a biological source is the same methane molecule coming from a geological source. On a graph, they look identical. The readings from Gale Crater still exist. The spikes have not disappeared. The instruments are still detecting methane. What changes is the meaning attached to the signal. As competing explanations appear, the discovery loses something important. Methane had seemed valuable because it might point toward life. Now the same observation can fit more than one story. A rock-water reaction produces methane. Methane enters the atmosphere. The measurement arrives exactly as before, but the interpretation chart beside it becomes crowded. Scientists become more cautious. The gas remains real, yet it no longer stands alone as direct evidence. The search has not failed, but the margin that made the signal feel unique is getting smaller, and the question remains unresolved if methane is there. Which source is actually producing it? A fresh drill sample comes out of Martian rock, and attention shifts from the atmosphere to the stone itself. Inside Curiosity's onboard laboratory, the sample analysis at Mars instrument examines material from ancient mudstone. The results reveal organic molecules preserved in the rock. That discovery does not erase the methane problem, but it changes the picture. Scientists now have two observations sitting side by side. Methane has been detected in the environment, and carbon-based compounds have been detected in Martian rocks. The clues appear to point in the same direction. Confidence begins to recover. Headlines return. Diagrams that had split into competing explanations start showing connections between separate findings. The prediction becomes more specific. If life exists, independent signals should reinforce one another rather than appear alone. The compensation works, at least for a while. The life interpretation survives because it no longer depends entirely on methane. A drill sample leads to laboratory analysis, and the chain of evidence grows longer. The cost is that the standard of proof rises with it. Organic molecules can remain preserved for geological timescales, and their presence does not automatically mean biology. The discovery appears stronger than it did before, yet it now depends on multiple pieces fitting together. The question is still open: are these clues actually connected, or do they only appear to align from a distance? A laboratory result appears to support the story, and then another laboratory result begins taking it apart. Simulations of Martian chemistry produce familiar patterns. carbon compounds appear. Methane-like clues emerge. The observations still exist, but they are no longer behaving like exclusive evidence. Researchers test combinations of dust, minerals, radiation, and chemicals expected on Mars. Perchlorates enter the picture. Ultraviolet radiation enters the picture. Reactions that do not require biology begin generating signatures that look uncomfortably similar to the ones attracting so much attention. On a comparison chart, different pathways start arriving at comparable observations. The chain that seemed to be strengthening now bends under its own requirements. Methane was supposed to support the organics. Organics were supposed to support the methane. Together they appeared more persuasive than either clue alone. Now the same collection of clues can be reproduced through non-biological chemistry. Earlier interpretations are revised. Diagrams that once showed multiple lines converging toward a biological explanation gain new branches leading elsewhere. The observations remain interesting. The chemistry remains active. Curiosity's measurements do not disappear. The rock samples do not disappear. What disappears is the verification margin. The most exciting explanation becomes harder to defend because chemical pathways can generate remarkably similar outcomes. Multiple clues no longer guarantee the same conclusion. By this point, the evidence can still suggest something unusual on Mars, but it can no longer be trusted as proof that life is responsible. The question survives, yet the answer now has to compete with chemistry that keeps producing the same signals. The original methane graph remains on screen. The line still rises above the baseline. The measurements are still real. Nothing about the observation itself has vanished. What changes is everything built on top of it. Geological explanations remain viable. Rock-water reactions remain viable. Non-biological chemistry remains viable. As long as those alternatives survive, the key requirement never returns the ability to exclude abiotic explanations. The verification margin is gone. Scientists gradually step away from the strongest biological interpretation. The evidence has not been erased, it has been downgraded. A methane spike can no longer carry the weight it once seemed to carry because the same observation fits more than one mechanism. The sequence that opened the story now runs in reverse. A methane graph appears. Geological models expand. Interpretations are revised. Headlines become more careful. The most desired explanation becomes the least defensible, because it requires eliminating alternatives that remain on the table. Life was not demonstrated. That does not mean Mars is lifeless. It means the observations never crossed the threshold required to support that claim. The methane remains. The organic compounds remain. The chemistry remains. The signal survived. The meaning didn't.